let's jump to question number 7. So we have two objects with mass 1 kg and 7 kg, which are connected by a light string that passes over a frictionless pulley. To find the tension, acceleration, and distance each object will move in the first second of motion. Okay. So let's copy this diagram over. We're given the two masses to be 1 and 7 kg, and this is 7 kg. So the first step would be to draw the free body diagrams. Okay, so for the 1 kg block, as you know, the 7 kg is heavier, so the 7 kg block is going to go down, and the 1 kg block will be moving up. So it's moving up with let's call it M1A. Okay, the weight of the block is acting downwards, which is mg, and the tension in the string is actually pulling it upwards, T. Okay, and for the second block, which is the bigger block, we have the weight of the block pulling it down. The tension wants to resist it, so it's pulling it back up. And then the overall motion of the system is downward, so it's M2A. Note again that by the principle of conservation of string, we have the two accelerations to be the same. So A for both the masses is the same because the string as it moves pulls them at the same acceleration. Okay, so from this we can write the equation of motion to be M1A is equals to T minus M1G, and then for this one we would get M2A is equals to M2G minus T. Let's call this equation 1 and let's call this equation 2. If we were to add 1 and 2, we would get M1A plus M2A is equals to, the tension would cancel out and we would be left with M2G minus M1G. From here we can actually solve for acceleration right away. So we can say that M1 plus M2A is equals to G times M2 minus M1, and acceleration becomes G times M2 minus M1 divided by M2 plus M1, which is equals to 9.8 times M2 is 7, so 7 minus 1 over 7 plus 1. So 9.8 times 6 divided by 8. So we get 7.35 as the acceleration. So 7.35 meters per second square. Okay, so now that we have the acceleration, we can actually plug this acceleration back into any of these two equations and solve for t. So we say plug A equal to 7.35 meters per second square into equation number 1, and we would get M1, which is equal to 1, so 7.35 times 1 is equals to T minus mg, so m was again 1 times 9.8. Therefore we get tension is equals to 7.35 plus 9.8 is equals to 17.17 newtons. Okay, so this is actually the solution to part A, and in order to solve part A, we actually found the acceleration as well. So we found the solution of part B as well. So part A, tension is equals to 17.17 Newton. Part B, acceleration is equals to 7.35 meters per second square. Okay, and part C, determine the distance each object would move if in the first second. So for time t equals to 1, how much would it move? So we can use the equation of motion. S is equals to ut plus half at square. Since we know that the initial velocity is 0, this term goes away. We can say S is equals to half of 7.35 times time, which is equal to 1 second, so 1 square. We basically get 7.35 divided by 2, which is 3.675. So both masses would move 3.675 meters in the first second. Okay, let's check the answer. So that's a free body diagram, which is perfect. We write the equation of motion and then we solve for A, which is correct. We get 7.35 meters per second square. From that, we plug it back into one of the equations and we get the value for T, which is 17.15 Newton, which is correct. Part B was already answered. The distance the mass will move in the first second of the motion. We used the equation of motion. Initial velocity is 0 and we get 3.675 meters. So perfect. So the solution is correct. Okay.